Yep. Sai che teoria boh, okay, environment, pie chart, classroom, so Let's start with our fancy Numpy. I will. Do you see the code, or you need to a bit enlarge it? Zoom it. Good, good. Okay, we have a Numpy array that is 1, 2, 3, 4, 5, 3, 2, 1. So how you will select sub array, for example, from the end. So your false. So for example, the sub array by using, oh, I do not need array, I will just print hello -1. So you're selecting -1. That's clear. How we can select all the elements minus 5 because 0, 1, 2, 3. So basically we can access it like minus 3, I think, minus 1. 0, 1, 2, 3. 3, 2. I selected. Yeah, we do not need the last one. We will go, yeah, in minus 4. So like we are, and if I will just go 4, then we will start 0, 1, 2, 3, and 4. So basically, I think we will start from the 4 or 5. 5. So you can do, so you can select the array indices by using the two dots. So if it is the same way, but only 2D, might be, okay, let's select another one. So from the first one till the third one. So 0, 1, 0, 1, 2, 3. Selected. We can do the same way, but select, for example, from the first till the fourth. The same way is possible with the 2D array. So we do not need that. We will need same copy. And maybe let's change it to 3, 2, 1, and 1, 3. And so now we can, if we will launch the same lines of code, we will get, so minus 1. We will select the last array. Okay. And if we will select from third to fourth, but since we have only 2 elements, they all will be included. So let's check out now the shape. We do not need that. Yeah. The last one. Okay, now we have, yeah, please. something in between. So, for example, we want to select some indices that are in the first row, might be, and the last column. Two square brackets. We can use that to select, for example, the first and the last one. Yes, we will select this three, but we also can use one. Yeah, I need to access that, and also we can use one because it's two shape. We can use, for example, one and minus one. Basically, it's the same way. We can then slice it up like from first to third to three to three to three. First row, to three. This one. Yes, correct. Then we can do from third, no, let it be from fifth to the end, and might be from the first, or might be, we do not write. We can put that to include first and the second row. So we doesn't care about that. So we selected from the first and further. So basically we cut the pieces. So in this subsection, we can select part A or how you part. Okay, let's create a copy. Copy and change it to 1 1 1. Change this part to 3. Okay, so now if we do the same way, we will select only from the fifth. So basically, this part, this block, we can do the same way to select, for example, the from the only from the second row and 5 to 7 element. Since we have 9, he will not blame us. Do not need that. Okay, so we have selected for 1 to 1 or 1 to 1. We have selected this sub piece. Then we can do the same way to create, to operate with the, for example, array of higher dimension. We can use like that. Like that. So now we have print array shape. So now we have array of the size 3, and now we could not select because we are not selecting the indices. So we have only first row, so we can leave that as two dots. How you call them? Okay, you can use a column sign to access each row. So for example, in our case, 1, then we will use from 5 to 7, and might be we will use from first to second. Let's see what we will select. Nothing. And if we will use everything, nothing. Because we have 4. We have only 4 from again this part. The second one. This is that one. So we selected from the first till third. So 3, 2, 1, 1, 1, 1. Just for fun. So, uh, the shape would be, I will add small command patch channels with height. So yeah, so I right now I will duplicate it, and now it's already 4 too. Run through the I will open the- I will open your today's work. Materials is already posted. Implement changing of angle spaces. Draft, assignment, sign, sign. So right now, please download the template of our source code that we will work on today. Open it and try to run. We have so if you run, try to run it. If you run, you will see not yet. Yes, we will do a bit from scratch, but you won't have like a regression today or the classification today. We'll just uh, get in touch with the classes and You will have them in the end of this week, maybe tomorrow or after. Next, you will work mostly with images. And this week is just for you to understand the basics. And might be you will write from scratch. And but again, when you defined everything in the object-oriented way, you have already your constructor, and you it's easily like a Lego. No problem. You run and you see this black small page. And then I call that error. So okay, let's go through the code and see what we have inside. So from the beginning, so let's go through the code. We have packages that we are importing, so which we were used today. Numpy OS, its operation system, so basically we can access like name of the system or blah blah blah. Matplotlib to visualize the like in this case the whole game. Then we select the backend which our Matplotlib will use. So basically, if it's Darwin, then use macOS. If it's Windows, or in all the rest cases, we will use CAG. Import matplotlib, blah, blah, blah. we are defining our space size, so basically the size of the window. We're defining some additional parameters. We include interactive mode, so it will register our keys, and we define our background. Next, there are some already to-do sections which we will implement slowly today. So rotation matrix, translation matrix, scale matrix, dot product, which is matrix multiplication, vector 2D to vector 3D. So we will transform our 2D array and the exactly opposite, 3D to 2D. So now you know why I was showing the 3D arrays. So that's why I knew it. Yeah. So we have static object, which is our first class. We have some vector position, direction, vector direction, geometry, angle, color, and we have our matrices, rotation, scaling, transformation, and C is that includes everything inside. So basically the whole transformation. We have set angle, get angle, update movement, update transformation, draw, and that's it. We can collapse it. Next, we have planet, the same way. Init, update movement. So you see that if we're using static object, we have already inside update movement, and we are defining it as pass. And then we can, for example, implement, so planet now uses static object. Our log was using blank, and it already have update movement inside, and we defined its own movement transformation. So, for example, for the planet, it would be 1, for the asteroid, 1, for the spaceship, it could be another one. So we're operating with the uh, objective programming. Okay, we have planet. We have now the same way static object, but now we have movable object. The same update movement. So we just use the same features that were inside the static, but additionally we add speed and update movement. Nice. Next one, asteroid. The same way from the movable object, we add additional color, geometry that we will implement speed, angle, transformation. Rocket. Same way as the previous one, we define additional features, additional methods. Player. From the movable object, we define its geometry, so it could be its location, speed, formation, activate thrusters, so basically add a bit more to the speed. I will, yeah. Update movement, the same way, get instance actors and update features. Close that one too. The game itself is running through, scores lives, blah blah blah. We have player planet already defined inside. We have asteroids for rage in 5, so we will have 5 asteroids. Diff vector position, so random location. Add them to the all actor. Vector positions. I guess currently it's defined where they are located. You generate a random integer between minus space size to randomly. So like yeah, you define where this place. Yeah. So you in the middle, in the center, blah 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 blah. What, in the forum? You are not interested in this variable. So I can write it like that for e in range, but I'm not interested in this I since I'm not using it, and to uh yeah. So I do not need that particular variable. I can do the same way with for example, is if something I'm I will do no, because it's the Python Yeah, you need. Like you can do the same way in Java for I in range 5, but you will not need it, and it will be additionally stored in the memory. So to economics, to not garbage it, we will save some place. So yeah, this is the game, and the game is inside the whole loop is inside the game. Okay, so we will close the init, the press. So if we are pressing each key, for example, escape, we close the game, right, set angle -5, left +5, up, activate raster, so add a bit speed, and it's a spacebar. Then we have fire rocket. Not needed. On close, set variable false, and main file, define our plot, and while is running, so while true, we clear the plot, we set up title, we put our limiters, and for actor in actor, so basically we're iterating through all the actors that we have, for example, player, asteroid, blah 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 blah. We update movement for them. So if player is moving, then we update it. Yes, yes. So you're putting limiters and be infinite draw, pause, and get instances to get particular instance of the game for the class static method. So yeah, this currently is all the code that we have. Let's try and see what we have in our first task. Implement so that using arrows you can change angle of the spaceship and display result using plot title angle. So first step, let's add our angle to our title. We have speed, we have position, and now let's add another one that will be angle. The same way, brackets. Uh, we need to get player get instance to get the particular player. So our spaceship, we are getting our spaceship, and then we can do angle. I think it is possible in this case. If we will run it, player has no attribute angle. I need it to be the same way, right, like that. Get angle. Because it do not have the attribute angle, but it have the method to get angle. And now, if I press my key left, I have 45, 50, 60, 90, and right. So I see that my angle is changing. So this is the first step. We added additional line of code to print out as the title of the plot uh, angle of the player. Uh, get angle. Declare. Not working. And what do, Yeah, yeah, yeah. In any kind of trouble, you can open the YouTube channel and there is the live stream. In case you are, I can, so you do not see purple. On the break, I will change the style of the methods from purple to something else. So we have our first one implements. We can change the angle of the spaceship. Uh, so okay, this one is done, I think. Yeah, we're changing the angle and we're getting the title in put title. So this one is done. Next one we will add our, since currently we're uh, your angle is not changing and you do not see that your key is basically pressed, you need to use another backend, which is QTAG, and then everything will. I have. I do not have the Q. It was this one. Yeah? I do not know all the names. Background. Uh, okay, so those have register, please register. Please use QTAG, but I do not have that one, so I will use the default one. So we have angle is working, key is registering. We are done with that. So I will open the next one. Assign, assign. So please open up the equation that you have. Place multiple asteroids in the scene. Equation use theta from 0 to 360 degrees with some random step. Also, you can randomly modify radius of asteroid to create a rigid surface. Implement at least 3 asteroids in random positions. Submit the content screenshots. Okay. So now we need to put inside 3 asteroids. So where we will do that? We have planet, planet, planet. We have already the definition of the asteroid inside, but let's check the asteroid. We do not have the geometry, so it's now a currently empty list, and we cannot draw. So we will create an algorithm for the circle drawing. So let's start slowly. I will do everything in my memory. In case of errors, I will switch to my backup code. So let's start. We will define self radius, which will be np random. There was np random. Yeah, here it is. See, so now we will have random floats in the 0 to 1. Let's add some scaling, so we will increase our size by, for example, 0 2, and let's now keep it as it is. Now self theta, which is basically this one, this symbol is called theta. Yeah, we have theta 0. Excuse me, I just want the variable. Yeah, I do not need that to be accessible from everywhere from the other parts of the code. I can use just theta. Now we need to be if our for or sorry, I do not remember this code. While theta more than 2 times pi or math numpy where is p? I see e, I see Euler instance, but I do not see p. P, nice, nice, math p, nice. So now we will have radius equals Cos. Let's implement this from line to line or not. I will switch to backup code, find this one so we would not waste our time. That asteroid. I will copy and then we will go from scratch to scratch. So then it will be with my memory will be a bit hard. So let's start. We define the same weight theta. While theta is less than 2 times p, so less than our circle, we will define radius, which equals self-radius, so basically our predefined, which plus random times something. So we are creating a radius randomly. We can print radius. I will put exit step step step. So let's print out radius and let's print out what we are appending here. F rad. Yes, yes, sure. F uh, X Y. And if we print it out, module is not callable. And per random. Oh, nice. So let's Uh, how many points? We will have print self. You will have 21 points. Yeah. Using cosinus and sinus and theta, we are getting the x and y coordinate for our geometry. The outcome is that we created some asteroids inside. But let's add. I will add additional. I will add the same way as it was here, just for fun, and I will increase this one by 0.4 and this one by 0.2. I think that the asteroids should be much bigger. They are not bigger. That so you can play with those numbers to increase, decrease size. The, check the task. Circle drawing equation. Also, you can randomly modify the asteroids to get the right first. Implement at least 3 asteroids from random position. Submit the code and screenshot. Yes, now we have 3 asteroids. We can launch them. We have, as I think that there is 3 because we defined them. I see them in the code, and there is 5. So you can change it as many you want. But yeah, so basically you are defining the circle. This is for the radius part. So edginess, roundness, and this is for the np cos theta plus radius x and plus radius y. Uh, 254 or 253 for loop. So we have that one. Let's implement rotation matrix, and then we will have small pause so you can a bit lower the pressure on your brain. So everyone has this one, this implemented, and everyone has. Huh? So now we have our asteroid. We need to implement a rotation matrix. Yes, sure. Uh, yes, please. Add some features inside, and it will be random everywhere. That's it. So now our task is, or have everyone upload and screenshot? Yeah, edit, time, time. So, are you ready for the next task? Code is uploaded. Okay, let's start. So, implement rotation matrix and make sure spaceship can rotate around its axis using template from the previous task. So, let's open the rotation matrix. Yeah, it's the same way. I will show you there. So now we have five, five, five. Sometimes rotate our inside the rotation matrix. So now it's just creating like this. this one, or you will open the assigned one. So basically it's the same way. Or I can just leave it as that one. Okay, I will leave it as that one. You have already degrees, but you have degrees. Here. So it would be rotation matrix identity free. Rotation matrix. So now you just at the moment because we need to add one line so the ship will rotate. I will just add Python numpy degrees to radians. Radians, yeah. Convert. Convert. I guess yes, that it is using the same way. So rad equals np dot. I changed the interpreter. You see that it's not recognizing the packages, but I have them already installed. So when I click, it should describe or tell me the information to help this function. But now it cannot find the declaration because of the packages and interpretation. So you have. Okay. By myself too equals so you can write it like that. So in case you are sacrificing its simpleness, like it's not one liner, it's not like that. You mean yes? I just forgot that to include that one. So yes, you can sacrifice a bit of some. Have implemented the rotation matrix. I will try to run it and see. Yeah, everything still works. Nice. And then we will add or change one line of code. Mm, it's already inside, so it should be working, I guess. No, it's not registering. Let me check. Static objects, planet, task. No. Oh, here you have 1106. You currently see Steve. All the all the applications for the reflection, translation, scale, whatever, rotation, shear in the one. Right now, change it to R, and if you will run it, our ship will be moving. Is it working? Yes, now you can submit. Not rotating after that, check out that you return the right matrix. R, return R. Because the biggest part have like mat and R is still equal to identity. So like that. And you are still returning the old one. You need to delete or comment it out and change the naming to this one. And then the ship will rotate. Uh, translation and scaling, for example. So then we'll use. So you can. I guess yes. I will be here. I think. Well, I will ask the your information center for that. But I think it Да, так, я пока что. Есть? Нет, сейчас подойду. Сейчас, секунду. Добавляю, что ли? Посмотреть дома. А, Есть?